In this section, we are going to learn about a new kind of product between vectors. Previously, we've learned about the dot product. In this section, we're learning about a new kind of product called the cross product. Now, the cross product is a little bit more complicated to describe. So before we jump right in, we're actually going to introduce a new idea that we're going to cover in a lot more depth later. We're going to talk about determinants. So to do this, we first need to talk about a matrix. A matrix is a two-dimensional array of numbers. So for example, 1, 2, 3, 4. Okay, and by two-dimensional, I mean it has both rows and columns. Okay, the rows and columns don't have to be the same number. Okay, in this example, we have 2 rows and 3 columns. Sorry, this should be columns, of course. We already have an example of one matrix that we've been dealing with for quite a bit. A vector is a special kind of matrix. In this case, we have 3 rows and 1 column. Okay, so 2 dimensions, rows and columns. We're going to learn how to take a determinant of certain kinds of matrices. A determinant of a square matrix is a number associated with the matrix. Now, this number, this determinant, actually tells us some pretty useful stuff about the matrix. We're not going to worry about that for now. We just need to know a little bit about the process of taking a determinant. I will just note that notice this only works for a square matrix. A square matrix is a matrix where that has the same number of rows and columns. Okay? So we define a determinant recursively. That is, we define the determinant of a square matrix based on the determinant of a matrix of a slightly smaller dimension with 1 less row and 1 less column. Okay? Which means you need to define a determinant for a 1-by-1 matrix, which is not a kind of matrix that we deal with a whole lot. So the determinant of a 1-by-1 matrix, which means 1 row, 1 column, right? I'll just call my element A. And we have a couple different notations for determinants. We could either write DET in front, or if we use the absolute value symbol, which isn't good for a 1-by-1, I'm realizing, so I won't write it. But if you use an absolute value symbol, you'll see me use it for a 2-by-2. That also means determinant. Okay? The determinant of a 1-by-1 matrix is just the single element. Okay? All right. Now let's look at a 2-by-2. This is where it starts to get a little bit interesting. Now, again, this is only a very brief introduction to determinants. We are going to learn that there are actually different ways we can approach this. But for now, all we need is a brief introduction. So determinant of A, B, C, D. And here, once we get to the 2 by 2, we could use those absolute value bars. We don't want to use it for the 1 by 1, right? Because it looks actually like an absolute value. An absolute value of A is not equal to A. We don't use 1 by 1 matrices very often, though. It's very rare. Okay? But the idea is if we expand along the first row, you're going to take each element in the first row, imagine canceling out the rest of the row and column, and you're going to multiply this element by the determinant of what's left. So A times the determinant of D, and then do it for the next element in the first row. So B times the determinant of what's left, which in this case is just C. Okay, and then alternate your signs, plus, minus, and that's it. It might be a little bit of overkill describing a 2 by 2 this way, but it makes more sense once we get to a 3 by 3. So a determinant of a 1 by 1, we know what that is. It's just the element, right? So I get AD minus BC. So a 2 by 2 determinant, AD minus BC. Okay? Okay. Let's talk about a 3 by 3. This is a bit more complicated. But you'll start to hopefully see the pattern. Same principles apply. And again, we have two different notations. You could use whichever one you find most convenient. The DET in front of a matrix or just the absolute value bars indicate that you're taking a determinant. Okay? So we're going to do the same thing. We're going to expand along that first row. Okay, so I'm going to expand along A. Imagine canceling out row and column. I can erase easily, so I can actually cancel it out. And then you're going to multiply A by the determinant of what's ever left over. Okay? So I have A times the determinant of E, F, H, I. Next element in the first row. I have B times the determinant of the elements that are left over. So B times the determinant of D, F, G, I. Finally, that last element in the first row, imagine canceling out the row and column. So you're going to take C and you're going to multiply it by the determinant of what's left over after you cancel the row and column. So I get C times the determinant of D, E, G, H. And then you alternate signs. So plus, minus, plus. Okay? And we know the determinant of 2 by 2s. And this will be usually the way we'll think about determinants, going from here to here. But there is a formula. Because we could take the determinant of a 2 by 2. We get E times I minus F times H. E times I minus F times H. Minus B, DI minus FG. Plus C times DH minus EG. And that's the determinant of a 3 by 3. Okay, so let's take a look at an example with numbers. Find the determinant of the matrix 3, 1, 2, 0, 5, negative 3, 1, 1, negative 2. Okay? So the determinant of the matrix, and I could either use the DET notation, or if I wrap the values of the matrix in absolute value bars, that means determinant. Okay. So, and I'll kind of write it out so we can see what's going on. I'm just going to make this real small here. And let's let me copy this. So most of the time you won't write this, but just to make it a little bit easier to see what the pattern is. Okay. We're going to take 3, cancel out the row and column. So I have 3 times the determinant of what's left. Okay. Next, I'm going to do it for the next element in the first row. Imagine canceling out the row and column. And so I get 1 times the determinant of what's left over. And once more, need to finish off that first row. So the last row or the last element in the first row, cancel out the row and column. And so I have the 2 times the determinant of what's left over. Alternate signs, plus, minus, plus. And now just take those 2 by 2 determinants. So 3 times 5 times negative 2. And then minus negative 3 times 1. Okay, minus 1. And then take the determinant of this 2 by 2 matrix. 0 times negative 2 minus negative 3 times 1. Plus 2 times the determinant of this 2 by 2 matrix. I have 0 times 1 minus 5 times 1. Okay, and so I get 3 times, let's see, negative 10 plus 3, that's negative 7. Minus 1 times, I have 0 plus 3, that'll be 3. Plus 2, and then 0 times 1 is 0, minus 5 times 1 is negative 5. So I get negative 21 minus 3 minus 10. And that's negative 34 is the determinant of the 3 by 3 matrix.